This is Thinking with Mathematical Models, Investigation 2, case number 36. We're looking at corn prices, and we're looking at how the demand changes as the corn price increases. And we're also looking at how the supply of corn changes as the demand and supply increases. So, first question, question A. I'm probably not going to write it out in handwriting. My handwriting isn't that great anyways. Why do you think the demand for corn decreases as the price goes up? Well, as the price goes up, we see that the demand is in fact decreasing. In other words, at some point, people are going to decide that, you know what, $3.50 for a dozen ears of corn is just not a good deal. I can't afford it. I don't want to pay for it, so I'm not going to buy it. So along the way, you're going to lose customers thinking that, you know what, that corn just isn't worth it to me to pay that much for it. Question B. Why do you think the supply of the corn increases as the price goes up? Well, if less people are buying the corn because the price is going up, then clearly there's going to be more supply of it because people aren't buying it. Also, as the price goes up, farmers are going to try to capitalize on the higher prices. So, you know, if they can sell 260 ears of corn 260 dozen ears of corn at $3.50, that's a lot more than selling 40 ears for $1. So there's more incentive for them to bring their corn to market when the price is high. Sorry. Now for question C. Questions C, D, and E are the ones that seem to give people some troubles. So let's take a closer look at those. We're being asked to write a linear equation that models the relationship between the demand, D, and price, P. First, let's talk about how they've written the question. Notice how they've used an italicized D and italicized P. That is a clue that you're being asked to use D's and P's instead of X's and Y's. Next, let's take a look at this really quickly. We're being told that we have a linear relationship. So let's go ahead and make a graph of that. Let's see what we get. So here we have a graph. I'll make it a little bit larger so you can read the labels. That's showing the price and the supply. But that's not what we want. We want price and demand. So I'm going to make that one much smaller. We'll bring out the other one. Sorry about that. So here we have the price versus the demand. And we have the data points plotted along the graph. And we see that this relationship is very close to linear. Is it perfect? No. But it's reasonably close. So when we're being asked to find the equation of a linear relationship, we have to use our linear model. We can't just take any points. We have to use our line of best fit. So for question 36, if you do not make a line of best fit, you're going to really be stumped. Once we have our line of best fit, let's find two coordinate points that we can use to make our slope calculation. So looking at this graph, are there any 2 points on this line that we know absolutely, I have the hiccups, sorry. We know absolutely the value of the x and y coordinates? Well, the first thing to look for is, do we have any crosshairs that this line crosses? We don't know the exact value for the y-intercept. Doesn't cross there, not close enough to that point here. Oh, right here, this does go through a crosshair, and it does actually end up being a data point, which is convenient. So we have one right here. Now that one's a little off, so we can't use it. It's further off, not so much, but we do have a data point here, an exact data point. And then as we go through the line, well, it looks like we almost go through here. So if you really wanted to, you could probably use that one, but it's still a little off, so maybe not. So really, we are stuck with using these two data points that are on my line of best fit. Now, clearly, you could have made a different line of best fit, but this is the one that I made, and so I'm going to find the equation of it. So, we know that this point right here is at 1.5, comma, 175. And we know that this point here is at 3, comma, 80. And I know this because I'm looking at these data points here. So let's examine the rise. Well, I know I'm going down when I'm looking at the graph from left to right. So if I'm going down, that's telling me that I'm moving in a negative direction. So I have a negative rise. And I can't just count the boxes, and I don't know how far down I go anyways. So I have to look at these two values. I'm going from $1.50 to $3. And I know that is I'm using the wrong values. That's funny. I'm going from 175 to 80. So what is the difference between 175 and 80? If you said 95, you'd be right. So I have a rise of 95. Now let's look at the run. Well, again, I could count the boxes. I have 3 boxes, but each box is not worth 1, so I can't just count the boxes. I have to look at where I started and where I ended. If I'm starting at $1.50 and I'm ending at $3, that means I have a horizontal change, or a run, of 1.5. So if I'm looking at slope, we know that the slope is going to be negative 95 over 1.5. And this is kind of an ugly number. We don't really want to have a fraction inside of another fraction. So the easiest thing to do at this point is to go ahead and use a decimal equivalent. So if I look at 95 divided by 1.5, I would get roughly, and this line of best fit is an estimation here, would roughly get a slope of 63. Now you'll notice that this says 63, but, I'll put that right here, but I have to remember that I'm dividing a negative by a positive, and dividing by a negative by a positive would give me a negative. So I know the slope is negative 63. Next, looking at our y-intercept. Now our y-intercept is right here. In this context, it would be reasonable to make an estimate for your y-intercept. We could, however, also find an exact value. So let's make an estimate and then find the exact value and see how close our estimate was. If each line here is worth 25, then I would say this would be about 10 above this 250 line. So I would say this is right about 260. But it's an estimate, we'll see. So right now I'm postulating that the y-intercept is 260. Well, we could find out. So what I'm going to do is I'm going to take one data point. I'm going to take this one because there are no fractions. And I'm going to use my y equals mx plus b. And let's see what we get. So my y value is going to be 80. So I know I have 80 is equal to, and my slope, and I'm going to, just for this, I'm going to use the whole slope. I'm going to use 63.3 repeating x plus b. But wait a second, what's my x value? My x value is 3. So I can go ahead and I can erase the x, and in its place I'm going to substitute the number 3, because 3 is my x value. So let's go ahead and multiply my 63.3 repeating, and it's negative, right? So by 3. And so we get 80 is equal to negative 190 plus b. Well, what's the opposite of subtracting 190? Adding 190. And so we have 190 plus 80 is equal to 270. And I'm reasonably close with that estimate, but not exact. So let's take this value for my b value. So our final equation is going to be y is equal to negative 63x plus 270. But wait a second. You remember we started with different letters, didn't we? So now we need to determine which is d and which is p. Is demand the y value, or is price the y value? Well, I can look on the y-axis and I can see that demand is there. So really, we do have our y equals mx plus b equation, but we need to use the variables that are listed in the problem. So since demand is on the y-axis, we have d is equal to negative 63. Price is on the x-axis, is equal to, plus 270. So let's double check, see if I've done everything that I'm supposed to do in part C. We're being asked to write a linear equation that models the relationship between demand D and price P. I'm using the D and P, and I have my mathematical model that I found the equation of. So that's what I have for question C. Now this video is on the verge of getting really long, so I'm going to speed things up a lot by saying the next thing that you're supposed to do for D, which is basically the same question but only you're looking at supply and price. You're going to take this graph and do the exact same thing. And in this case, I made a line of best fit that goes through this data point, and I try to make it go through that data point. So I can actually make my slope calculation here, and then I can work the same way I worked in C to get my y-intercept. Finally, E, use graphs to estimate the price for which supply equals demand. So for that one, we need to have both graphs on the same axis, and that's actually sort of interesting. I'll go ahead and do that. Oops. So what I'm going to do is I'm going to make this graph fairly transparent. I'm going to grab this one, and let's see if we can't enlarge. Shoot. Okay, I'm going to send it to the back. So I'm going to enlarge this one. We have to enlarge it so that the scale is the same. That's pretty close, folks. So I'm going to make that one transparent too. And so I can see that the lines cross. It's pretty close. I can see that the lines are crossing right about here. So I'm estimating, and I know I'm a little bit off because the scales of the graphs aren't perfect, but I can see that at about $2.25, we're going to have where supply and demand meet. And this is actually the price where the farmers really want to put their corn. That's where they'll maximize their profits. So that's how you can go about doing that. I hope that was helpful, and I'll see you tomorrow.